Yeah, not equal to. The last one means not equal to. Yeah. All right, so we're pretty familiar with these inequality symbols, right? Each one of these represents the inequality symbols, and we've spent a lot of time before working with them. Today, we're going to talk about how to graph them and then graph some systems. So the first thing we're going to talk about is a basic inequality. 3x plus y minus 6 is less than or equal to 0. All right, well, to start all these off, we want to get them into y equals form. So that means I'm going to say that y has to be less than or equal to a negative 3x minus 6. Is that right? Thank you. Thank you. So we want to put it into, what do we call this form again? Slope-intercept form. That's the one. Yeah, put this into slope-intercept form, right? Which one represents the slope? The negative 3. And which one represents the y-intercept? The 6. Good. Okay. So I have 3x plus y minus 6 less than 0. So let's bring this up. 3x plus y minus 6 less than or equal to 0. All right? So if I'm going to graph this, how do I graph this? What do I do? What was that? How do you graph the line? Yeah? And we had less than or equal to. Oh, yeah, it sure is. Thanks a lot. Should be a y, huh? That should be a y, huh? Very good. Okay, now I'm all good to go. All right, so 3x of y. So, yeah, let's pretend it's just a line for right now, right? Let's go up to 6, right? And we'll put a dot there. And then from the 6, what do we do? Go down 3. 1, 2, and 3. And then over left or right? Right. Always to the right one. Good. Do your best to draw your line on your graph paper, right, with your ruler. And how do I know that my line is solid in this case? Yeah, because equal to. What if that said less than? It'd be a dotted line. Okay, good. Now the question is, which way do I shade and how do I know? Okay, good. Well, let's take a test point. Well, we could test 0, 0, right? 0, 0. So if I was going to take a test point, is 0 less than or equal to negative 3 times 0 plus 6? Yup. 0 is less than or equal to 6. So that seems to be working out pretty good for me, right? So I want to go to the left. What if I did not know that? What if I did not know that, and I took a test point, say, I don't know, 4, 1 over here? Well, what would that do to my inequality? That would make it false, yeah. Yeah, if I took 4, 1 into my inequality here, I could see that 1 is not less than or equal to negative 3 times 4 plus 6. So 1 is not less than or equal to negative 6. That doesn't make any sense. So therefore, the way that I'm going to shade this is to the left. And what I'm going to do is I'm going to clear everything here. I'm going to clear my ink. And I'm going to put this onto my graph, and you should see something. Hey, there we go. So I've got my line here, and I've got everything shaded to the left of my line. So I'm going to copy that and bring it back into our notes, okay? So we can talk about it. And there we go. Hey, there we go. All right. And there we go. That's a pretty standard, straightforward, easy kind of question. Does that ring a bell to you? Yeah, no problem, right? Okay. But well, the cool thing is that we're not limited to lines, right? It doesn't have to be lines. We could actually use conic sections. So I got x squared plus y squared is less than or equal to 4. All right, what is this the conic section of? An ellipse, you think so? What's the value of A?
4.
No. 1. What's the value of B? 1. Are they the same? So therefore, this is a circle with a radius of what? No. 2. There you go. Circle with a radius of 2. I know you are. I know. So we had x squared plus y squared is less than or equal to 4. Well, in the last case, we had a line, so we took a test point above and below the line, right? In this case, what do you think intuitively? Everything inside the circle. Let's see here. And there you go. Everything is graphed inside of my circle, right? What would happen then if I reverse the direction of the inequality sign? It'd be everything outside the circle. So let's go ahead and have a little bit of fun. Let's go everything outside the circle. And there, my graph completely changes to form everything outside the circle, like a little barrier, right? A circle of trust, if you will. Very good. So therefore, we want everything inside the circle. And again, I'll copy that and bring that over to our notes. And this will represent everything for us. And there we go. So we have our graph inside the circle. Okay, what do you think so far, you guys? Not a big deal, right? Okay. Stuff that we have seen before. All right, here we go. Now, whenever you graph two or more things together. Okay. Okay. I've got two or more things being graphed together. So what do we call that? There's a name for that. What's it called? A system. Very good. Yep. All right. So before we can graph this, we have to get it into slope-intercept form. So let's get this into slope-intercept form. Y is going to be greater than or equal to negative x plus 2. Let's get this into slope-intercept form. I have negative y is less than or equal to negative 2x plus 4. All right, what is my warning here that I'm going to tell you about? Yeah, whenever you multiply or divide by a negative number when dealing with an inequality, you need to reverse the direction of the inequality sign. So y will be greater than or equal to positive 2x minus 4. So here are my two inequalities that I am working with. All right, let's graph both of those and see what they look like. So I had, can someone help me out? Y was greater than, equal to, negative x plus 2. Very good. 2x minus 4. All right, so again, graphing the first one, all right, we see that we have a y-intercept of positive 2, which makes a whole lot of sense for us, okay? And then we go have a slope of negative 1, so we're up here at negative 2, and we're going to go down 1 and over 1. So there's my graph that supports that. And notice I want everything to the right or greater than negative x plus 2. Pretty good so far, right? Okay, the next one, I'm going to go down at 4, put a dot, and then go up 2 and over 1. And I should see an overlapping region here. So when I graph the second one, and I want everything above that line. Now, it's kind of hard to tell with this particular program. So what I'm going to do is I'm going to bring this back over and do some highlighting for you while you guys graph it on your page. Oh, that's a good question. All right, so let's talk about the red graph here. The red graph was everything above this line here, right? So we wanted everything up here. Any point in this yellow shaded region will satisfy the first inequality. Any point that you pick will satisfy the first inequality. Now let's go with blue, and let's go to the left here. Ooh, check this out. Notice I have color changes. Anybody see it? Ah, that's pretty neat, right? Pretty fancy. Okay, so any point in the blue region will satisfy the second equation. What is the overlapping part? That's exactly right. Anything in this region here, right, will satisfy both inequalities. Therefore, that counts as a solution on your own. All right, please try x plus y less than 2, less than or equal to 2, excuse me, and x plus y greater than 0. Try that. All right, so we should have found that everything for the blue, I'll use blue for the blue equation here. Oh, wait, they're reversed, huh? Huh, we'll go red here, pink. Okay. So everything for the red was sort of down here below this line, right? That's pretty bad right there. And then everything for the blue was sort of above this line.
Whoa.
Okay. So what we're looking at is an infinite amount of solutions in between. We're looking at an infinite amount of solutions in between those parallel lines. So one thing I want you to take away, the difference between inequalities and equations for systems is in systems of inequalities, you can have parallel lines and still have solutions. But if you had parallel lines for equations, there would be no solution because there would be no common points. So that's the difference between the two. Okay, the last activity we're going to do today, last thing is using fun with the graphing calculator. So take your graphing calculators out. All right, take your calculators out, turn them on, and go to y equals and make sure nothing is in the mode up there. All right, the first equation that we have is a parabola, right? It's x squared minus 4. And where's the vertex for that parabola? No, not 0, 0. 0, comma, it's staring at you in the face. -4, yeah, right? Let's move down 4. So let's punch into the calculator. So I have x squared and then minus 4. So there's my parabola. If I hit graph, we would expect to see just the regular old parabola, and the vertex has been moved down 4 units from the center. Okay, you can graph inequalities on the TI-83. Here's how you do it. Go back to the y equals, move your cursor to the far left of y sub 1. If you push enter one time, notice it changes the line from a normal line to a thicker line. If you push enter for a second time, notice you get an upper bound triangle. If you do that, that's the equivalent of greater than. Watch. Everything greater than the parabola. Pretty sweet, right? If you go back to y equals and you push enter again, you can show lower triangle, lower bound. That's everything that's below the parabola. Pretty darn cool, right? So we can actually get some pretty artistic, cool-looking graphs from here. Well, for ours, we want everything greater than, so let's go back, and let's change this to greater than. Now what you have to do is just keep pushing enter until you recycle through and get to where you need to be. So I want upper bound. Okay, next, my second equation, if I solve this for y, I would have y is less than or equal to negative x plus 2. So I'll put that in there, negative x and then plus 2. Please use the negative sign, not the minus sign. And do we want everything above or below? There you go. Let's go. Enter, enter, enter. And you should see this picture. Here's the parabola. And there is our line. And we're looking for the little piece in the middle that completes all the solutions for this system of inequalities. Pretty neat, right? In terms of what? Tell you what do you mean? Oh, no. 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 It's just a region, right? It's the shaded region down there. Okay, so right now, take a moment in time and create a beautiful picture of art on your calculator. Ready to go.